Hello everyone, let's start our today's class. The topics we are going to cover today is ideal and non-ideal solutions and their examples. In non-ideal solutions, they have two types. One is positive deviation and another one is negative deviation. Let us learn all these point wisely. Point number 1. In ideal solution, it obeys the Rolle's law. Obeys Rolle's law. Previously, I did the video about the Rolle's law. If you are interested, go and see. And in positive deviation, does not obey the Rolle's law. In negative deviation, does not obey the Rolle's law. In second point, total pressure is equal to total calculated pressure, that is PA plus PB. I will write it as PT observed is equal to PT calculated pressure. What is calculated pressure? PA plus PB. In positive deviation, PT observed positive than PT calculated. In negative deviation, PT observed less than PT calculated in negative deviation. Third point, IMF, intermolecular forces between solvent and solute are equal to solvent and solute. IMF between solvent and solute are equal to solvent and solute. In positive deviation, IMF between solvent and solute are greater than solvent and solute. IMF between solvent and solute are greater than solvent and solute. In negative deviation, IMF between solvent and solute are less than solvent and solute. IMF between solvent and solute are less than solvent and solute. And fourth point, the enthalpy of mixing should be 0, that is delta H mix is equal to 0. Delta H mix is equal to 0. This signifies that no heat is released or absorbed during mixing of two pure components to form an ideal solution. And second point, the volume of mixing is equal to 0, that is delta V mix is equal to 0. This means the total volume of solution exactly same as the sum of the volume of solute and solution. In positive deviation, the enthalpy of mixing is positive, that is delta H mix positive 0, because the heat absorbed to form new molecular interactions less than the heat released on breaking of original molecular interactions. And second point, the volume of mixing is positive, that is delta V mix 0. As the volume expands, dissolution of components A and B. In negative deviation, the enthalpy of mixing is negative, that is delta H mix 0, because more heat is released when new molecular interactions are formed. And second point, the volume of mixing is negative, that is delta V mix 0, as the volume decreases on the dissolution of components A and B. Now let us learn the examples of ideal and non-ideal solution. An example of ideal solution is bromoethane plus chloroethane. Bromoethane plus chloroethane. Same molecules and also it belongs to the same families. And next example is benzene plus toluene. Same sounding, methyl chloride, ethyl chloride for this type, ethane, propane. And this is about the examples of ideal solution. And now come to the positive deviation. The pressure is high in a positive deviation. When will the pressure be high? When the interactions in the liquid is poor, then their escaping tendency will be high. Only then will there be more vapor, then only more vapor pressure will be applied. The example of positive deviation is CCl4 plus C6H6, carbon tetrachloride plus benzene, CCl4 plus CH3OH methanol, CCl4 plus C2H5OH ethanol, C2H5OH plus water. These examples you can remember directly. And now come to negative deviation. Example, HNO3 plus H2O and plus CHCl3. It is famous word in NCERT, acetone plus chloroform, hydrogen bonding. Yes, you must have heard by now that the foam would have hydrogen bonding. Hydrogen bonding occurs when a molecule contains hydrogen atoms bonded to fluorine, oxygen or nitrogen. And chloroform plus acetic acid, CH3COOH. And next example, HCl plus H2O. And these are the examples of ideal and non-ideal solution.